So tell me, do you remember when you were a toddler and the only people you were connected to were daddy and mummy? And how as you grew older you met more and more people in school and in university? And once you started using social media, your network became really complex and messy? The networks that we're dealing with nowadays often look something like this. But how can we understand these complex networks and how nodes are connected? A way to begin with is the degree distribution. It is the probability distribution of degrees, meaning that it shows the probability of a node to have a certain degree. It also gives a basic understanding of the structure of a network without so much as defining it. Two very different networks can have the same degree distribution. So, to exemplify, let's have a look at a very familiar distribution. In a normal distribution, we see that the probability of being lowly or highly connected is relatively low. However, the probability of having a degree similar to the average node is much higher. Simply put, this means that there are many more people with an average degree than there are people with a low or high degree. But in real life, it actually looks a lot different. What we observe is a phenomenon called the power law distribution. Let's take an example with Kiki. She has a Twitter profile with 10 followers. The truth is that there are actually a lot of people who have more or less the same amount of followers as Kiki. Therefore, the probability of a randomly chosen person to have a similar degree as she does is quite high. On the other hand, Donald Trump, by sharing quality content and interesting ideas, has managed to amass over 7 million followers. Such a tremendously connected person is seldom encountered, so the probability of a randomly chosen person to have a degree which is similar to that of Donald Trump is really low. And that's what a power law looks like. There are many lowly connected nodes which occur with a high probability and few highly connected nodes with low probability. We see this distribution in a variety of real-world contexts such as World Wide Web links, earthquake sizes, or family name commonality. Overall, the degree distribution can help you learn a lot about how people are connected in your network. It can help with making inferences about how likely a node is to be connected to a given degree. And it also gives you an idea of the high-level structure of your network. It hints at the existence of clusters or hubs, but also at a possible periphery of isolated nodes. At the end of the day, the degree distribution is just a simple way to depict the connectedness of your network and get a basic idea of the structure it has.